We're now going to look at derivatives, and I say derivatives on derivatives because we're going to get into second derivatives as an example as well. But I want to show you some of the functions, the ease with which you can use native language to perform complex mathematics, and show you some of the features as well. So if we go to the second slide here, and what I've done is enter, using native language, native tongue, derivative of x squared. And I want to look at this derivative from -2 to 3. Enter that in the Wolfram Alpha entry bar, and it computes the derivative, and the derivative of x squared is just 2x. Derivative of x to the n is n times x to the n minus 1, according to the power rule. So it calculates the derivative as well as plots it on the graph from -2 to 3. Now, using the Wolfram Alpha entry bar and the nomenclature, understanding a little bit about the interface, I've got this function x squared, and I want to plot the derivative of x squared, and so I put a comma, and I want to compute the derivative, and I want to compute the second derivative of x squared from -2 to 3. And here's where it gets real interesting, because we've actually got three functions. The original function y equal x squared, I want the derivative f primed of x squared, and the second derivative f double primed of x squared. And all three of the plots are put on the same graph. This is very powerful for helping one learn to visualize what's going on with the function, the derivative, the second derivative. Here it's a simple function, x squared, but you can see from -2 to 3 what's happening. X squared is the blue line here. 2x, the derivative, is shown in the red line. And the second derivative, meaning the derivative of 2x, which is just 2, is shown on the graph as well. All three of the graphs. So this is a real important function of Wolfram Alpha, the ability to overlay multiple graphs on top of each other to really explore deeper what's happening in mathematics. And you do that all simply by entering the commas and separating it out in the entry bar. Now if I go a little bit further, let's say, well, that's from -2 to 3, but I really don't want to look as x goes from -2 to 3. I want to really zero in right around the 0 here, and what's happening to my functions, my derivatives and second derivatives at a different distance as x goes from -0.5 to 0.5. You do that, and so you can zoom in, zoom out very quickly. And this is another powerful function, not only for solving calculus. We're now into beginning stages of calculus, looking at derivatives, but some of the ways you go about tapping enhanced features of Wolfram Alpha.